Hello, everyone, and welcome to the Certified Information System Security Professional Training. So, moving towards domain one, security risk and governance. Indeed, an important domain, and from an exam perspective, interesting one. I see a lot of people say that it is something a completely theoretical based, and they might tend to lose a focus because they do not have any working experience on this, or they are slightly from a technical background, which is clearly understood. But it is, trust me, it is one of the most interesting domains, and it is even one of the most scoring domains. You are definitely going to get a lot of questions out of this, and they all are pretty good scoring ones. Okay, so we do not want to miss that. Each domain has been separated into different modules. This has been done to ease the pressure on just going through this all the slides one by one. After each module, we would be doing some kind of review activity, just assess ourselves that how well we have understood the concepts. Okay, now domain one, security risk and governance. It includes four different modules. The module one, we're going to talk about security governance through principles and policies. So in this module, we're going to understand very basic about security as and what is CIA. CIA is confidentiality, integrity, and availability. This is one of the important concepts that we have to carry with ourselves throughout the 8 domains. It might look very simple. Indeed, it is very simple, but the context of the CIA and how it is relevant from CISSP perspective, that we have to see. Okay, this is something that I've also included in our examination mindset, that whenever you think about security, think about CIA, because this is what we're going to do in order to protect. These are the three things that we would try to achieve through security. The next is about personal security and risk management concepts. So we are going to talk about a lot of concepts about risk management. How does the risk management is performed? What are the types of risk management? And what are the various methods that we follow? And what are the various things that we need to understand and take care from a personal security perspective? Now, what is a personal security? Like human safety, people safety. Then we have business continuity and planning. Now, earlier, when the CISSP was restructured from 10 domains to 8 domains, business continuity and disaster recovery used to be one single domain and a different domain altogether. Well, they have included now BCP, or business continuity planning, in domain 1 under security risk and governance, because BCP talks majorly about the policy perspective. DR is from an operations perspective. Okay, DR is your operations perspective. And we're going to talk more about BCP and DR when we reach there, but just to give you a quick understanding, and it makes sense. So that, because DR is your disaster recovery, is from an operations perspective, it has been kept into domain 7, which talks about security operations. Then module 4, it talks about a lot of laws and regulations and compliance. What all are the things that we need to understand from various laws perspective? It's indeed important, highly testable, but not everything. Okay, CISSP is your vendor neutral exam. What is vendor neutral? It doesn't talks about a specific technology which is provided by any vendor. Okay, it talks about the method. It talks about the frameworks. It doesn't talks about that how does a cloud in AWS looks like. It just talks about general cloud. Okay, all right. Module 1, security governance through principles and policies. Now, before we go ahead and get started, like I said, it is very important for us to understand three triad. We call it as three triad of security, or three principles, as CIA. It's confidentiality, integrity, and availability. Okay, now we all have heard about these terms. We all have been using it in our day-to-day lives, which is totally understandable. But how confidentiality, integrity, and availability impact security in a much more granular way, that's where we're gonna understand. Now, what is confidentiality? Confidentiality is sharing of information with the intended audience, intended people. Now, information or a data, something which is only meant for a small group of people. Okay, that small group would only have access to the data. Okay, that it means this particular information is confidential for them. Okay, so whenever we want to share any information with the intended audience or intended people, it means we are trying to achieve confidentiality. Any person who has access to this information outside this group, if someone is trying to access this information outside this group, what does it mean? It means this particular person has an unauthorized access to the information. Okay, now data should be protected in all states. Now data has several states, and we're going to cover in domain 2 about the states of the data and how do we protect it. But let's have a high level understanding about the states of the data. Now data on a high level have three states. What are the three states? Data could be at rest. What is at rest? It means it is stored anywhere, like your database, like your file server, or anywhere where data is at storage level or at rest. It is not moving anywhere. What do we call when data starts moving? We say data is in motion or in transit. Okay, so like your emails or your web traffics like http or any kind of file transfer, they all belong to data in motion. Okay, then what is data in process or data in use? We also call it as data in use. Like when someone is actually accessing a data or processing a data, like your memory, your ram is a good example of your data in use. So we need to make sure that we protect our data in all states. We need to achieve confidentiality, because right now we are talking about confidentiality. We would try to achieve confidentiality of the data at all states. Okay, now you would see several exam tips throughout the slides. Okay, these tips have been in order to understand from an exam perspective. All right, now whenever you get any question in your practice test or even in your real exam, that what is the best practice to achieve confidentiality or to maintain confidentiality, the best practice is we always encrypt the data. Now what is encryption, what is decryption, we're going to talk in our domain 3 when we're going to reach there. But just to let you know, encryption is a method where we convert any plain text, okay, by passing it through an algorithm using some keys to make it into a ciphertext or an encrypted text. That's what encryption is. This encryption is kept or encryption is done just to make sure that only authorized people who have access to this key or any other keys, we are going to talk more about what all are the algorithms, what all are the keys in when we reach there, but only authorized people can decrypt. Now what is the decryption process? When we convert the cipher text using the same algorithm using a key to back to the plain text. Okay, we hide the data from any unauthorized access so that only authorized people can look into it. And how does an authorized people can look into it? With the same process, just reversing the process of how does the encryption has worked. So this process is called as encryption. Okay, and this is decryption. Okay, now for encrypting the data in motion, the best practice is TLS 1.2. We're going to talk more about what is TLS. TLS stands for transport layer security. Okay, just do not get worried about these terms and jargons. We are going to cover each and everything. Okay, and for encrypting at rest, it is going to be advanced encryption standard or AES 256. Okay, we are going to learn more about what is 256, what is AES, all about when we are going to cover in cryptography. Okay, the reason I've kept it here because when we're going to talk more about cryptography, it is going to a good revision and your mind will start exploring the things that we are discussing on the very first day. That this is something that we learned in very first day of our class, right? Okay, so this is an exam tip. It is definitely going to be helpful throughout your practice sessions, throughout your even in your real exam. All right, now I'm just trying to mention few examples of confidentiality requirements. What all are the requirements that we need to achieve in order to maintain the confidentiality? So your sensitive data. Now sensitive data means your personally identifiable information, PII. You're gonna hear this term quite often, PII, and you must have been hearing this term in your organizations as well. PII is your personally identifiable information, which means an information or a data through which you can identify any individual. And PHI is your protected health information. We have few people in our group who has experience into healthcare industry, so they have been dealing with PHI data throughout their days, every day, right? So PHI is your protected health information, which reveals any kind of medical information or any medical record for any individual. Okay, so as per the law in United States, which is called as HIPAA, okay, we're going to talk more about HIPAA as well. Okay, so we need to protect our health information as well. Okay, so all the sensitive information must be protected against disclosure. What is disclosure? Disclosure is just opposite of confidentiality. Confidentiality is to maintain the secrecy of information. Disclosure is when we are revealing that. Okay, so all the sensitive information must be protected against the disclosure, against using approved algorithms. Now what all are the approved algorithms? These are the approved algorithms. Okay, now just like your PII or PHI, our passwords are also considered as sensitive, because if anyone has access to your password or credentials, your systems could be accessed by any unauthorized people. Okay, so we all understand the significance of protecting the passwords, right? So all these passwords and sensitive information, if we cannot encrypt it, they should be masked. Now what is masking? Masking is again one of the process of hiding a data. So you must have all seen the statements of your credit cards. How does it come? You have your credit card numbers like this, right? 1 2 3 4, the first four digit is visible, then the next four digits are like this, again the next four digits are like this, and last four digits are like this, right? So what we have done here is we have masked it. Or even when you enter your credential, whenever you enter your password in order to access it, right, it is replaced using asterisk or any other character like a simple dot. What we are trying to do is we are trying to mask your credentials here. Okay, then the sensitive materials has to be, whenever there we are about to store anything, it has to be stored in a protected way. It should not be stored in a clear text. Clear text means anyone can read it. It's visible to everyone. Doesn't matter if the person is approved to read or not. Okay, although passwords are something that all should never be kept in the clear text, doesn't matter if someone is able to even or authorized or not. I mean, only the person to whom that password belongs, they should be able to see it. Okay, even they should not be able to see it, they should remembering it and they should type it in. Although we have a feature like when you see an eye being drawn here, when you click on that eye, the password is revealed, but that's only till the time you have clicked it, just to make sure that you are typing it in a correct information. All right, now like I said, TLS is the best practice to encrypt the data in motion. Okay, now what exactly TLS does? It actually provides you a secure channel, right? Secure channel in which your data which is being sent, which we also call it as a message or a payload. Okay, it is in encrypted format, so no one can see it. We're gonna also understand how does the TLS and SSL works. Like whenever a client and a server, before they establish the connection, how does a secure connection established, that we're gonna see. Okay, but as of now we'll leave this concept when we're gonna cover it. Just understand TLS is one of the method that is used to encrypt the data whenever we are transmitting it in transit over the network, over the channel. Okay, right? So we should be using approved method, approved algorithms, and approved technology to protect the data, and we should not be using it something which is not secure, just like your FTP. FTP is your file transfer protocol. A protocol is used to transfer your files from one place to another, right? But it doesn't offer any protection. Okay, instead we should be using a secure way of transmitting the file like SFTP or FTPS. Okay, so it uses SSH, it uses SSL. Okay, secure shell and secure socket layer. Okay, we're going to cover everything, even the SSH and SSL as well. All right, another example which is listed down here, that log files should not store any sensitive information. We all know what are the log files, and it is important that our system is capable of capturing the logs. What is log exactly mean? So any activity that an individual is doing, a system should be able to capture it. Okay, a system should be able to capture it, so that just in case something bad has happened to the system, we should be able to review all the logs to identify what is the reason this event has happened and what are the things that we can do in order to prevent the occurrence of such event in future. And also an important factor, we can also try to trace back the individual who might have done that, so that what we are trying to do, we are trying to hold someone accountable, right? But these logs should not be capturing any sensitive information. Let's say I am accessing any system and I'm entering my credential. It should be able to capture that Prashant has accessed the system, what is the time and what is the activity that he has performed. It should not be able to capture my credential, my password. That is a bad practice, because just in case, if because logs are normally accessible to the people who might want, like system administrators are there, or people who are trying to perform the forensics on any impacted system. So the password should not be revealed, any kind of sensitive information should not be revealed. Okay, moving towards the next slide, where we're going to talk about the next triad of security, which is integrity. Now what is integrity? Integrity simply means we want to protect the unauthorized modification of our data from any authorized or unauthorized people. Okay, I'm going to repeat the definition once again. We are trying to prevent our data from any modification What kind of modification? Unauthorized. Who's going to modify the data in an unauthorized manner? Anyone. Even person is authorized or the person is unauthorized. So even a person has authorization to look into the data, but they do not have an authorization to modify it. If they are successfully able to modify it, it means the integrity was impacted. Okay, so we need to protect our data from unauthorized modification by any authorized or unauthorized people. Okay, we say that integrity was achieved whenever our data is consistent. Okay, when we say consistent, it means whatever the input was provided, the processing that happened, and the output was provided, it is maintaining the consistency and our systems are performing as it is expected to do. Okay, now let's talk about few examples. Code injection. Code injection is one of the attacks where an attacker tries to inject any kind of arbitrary code or malformed code into your system, into your databases to gain unauthorized access. One of the common example is your SQL injection, which we are going to cover while we are going to talk about OWASP. OWASP is your Open Web Application Security Project, and it includes all the top 10 vulnerabilities. You must have heard about it, right? A few of you definitely would have worked on it. But just to give you a quick example of how does a code injection works. Okay, now this is a technique which we can implement in order to protect against code injection attack. Okay, input validation. Now what an attacker is doing in the SQL injection, he's trying to input any malformed code, something like that. Okay, now if we are able to validate this input at our system level, whenever it sees that any kind of these characters should not be allowed, it means what the system is doing? System is performing a validation for the inputs. So this is a technique which can be used to prevent any code injection attacks. Okay, now what all are the various other examples and the methods that we can try and implement to achieve integrity? So integrity simply means ensuring the accuracy and reliability of the data. When we are going to achieve the accuracy and reliability? When our data is not modified in an unauthorized manner. Okay, few of the examples that is given through which we can achieve this method. So CRC is your cyclic redundancy check, checksums, message digests, hashes, and message authentication code. So what exactly these are? These are the ways through which you can see whether the message was or your data was modified or not. Okay, hashes, message digests, they all would be discussed in our domain 3, but I'm just going to let you know what exactly hashing is, just to have you an understanding so that you do not be in a situation that what exactly we are talking about. So hashing is a process whenever we provide some kind of input and pass it through some kind of an hashing algorithm. So I'm going to take one of the example like MD5. Okay, this is one of the algorithms of hashing which we're going to discuss. Okay, so what output we are going to get? If you want to get a hash value. Okay, now what is the significance or importance of hashing? If you have been given an input like any message, any plain text, and if you pass it through the algorithm, hashing algorithm, you get a hash value. But if you have given a hash value and you are asked to provide an input of it out of it, it is extremely difficult or impossible. Okay, the analogy that I use always, so what if I give you an orange and I ask you to pass through a juicer? What do we get? Orange juice, right? What if I ask you to build an orange out of an orange juice? Would it be possible? It's non-reversible, right? So that is what hashing is. Okay, it is a one-way mathematical function. Okay, now the important characteristic of any hash value is, so let's say we had a input as hello, and whatever the hash we got as a, like, let's say 123 125 abc, whatever we got. Okay, if we modify even a single character, so let's say I wrote HELL instead of O, I mentioned as 0, right? The entire hash value is going to change. Okay, right? So with this modification, you were able to understand or identify or detect that your data was modified. This is how you try to detect any unauthorized modification, and there you might want to revisit that how and why this got modified, and you might want to protect the integrity. All right, hashing, message digest, they all are the same things. Okay, CRC checksums, they also do a validation of the data once they receive to see if it has been modified in one or the other way. Okay, now what all are the things that we need to do or include when we want to have integrity? So we discussed about input validation. So input validation should be used in all the application. So an application, any application that we are going to see, it should treat all the input that it is going to receive as an untrusted, from an untrusted source. You need to build a system capable enough to identify all the or treat all the input that it is receiving as an untrusted, okay, so that it needs to validate all the input. Okay, so whenever an organization tries to procure any software from any vendor, right, whenever they have any software or an application being procured from the third party, the best practice is the vendor should also be including the hash of the code. Okay, so what would happen whenever an organization is trying to install that application on their infrastructure or on their systems, before installing it, they can verify if the code was modified. I mean, vendor has sent their own copy, okay, copy of the code. It also sent the hash of the code, right? Now whenever you have seen, and they would try to perform some kind of encryption so that this could be protected or something like that, and once you have received the code, you might want to regenerate the hash and compare it with the original hash that was created to see if it was modified anywhere. And if you see that the code was modified, probably you do not want to install it, because we do not have the integrity intact there. The code was altered. Someone might have included any kind of malicious code within it. So the moment you're going to install it, your system might be infected with some kind of malwares. Okay, then subjects should be prevented from modifying the data. Now who's a subject? Subject is an entity who requests access to the data. So it could be your, let's say, if a user is trying to access an application, in this case this would become a subject and this would become an object. Object is an entity which provides access to the data. Subject is an entity which requests access to the data. Okay, now if an application is trying to access a database to in order to retrieve anything, in this case application will become a subject and a database would become a object. All right, so a subject should be prevented from modifying the data unless exclusively allowed. All right, so if a person is should not be allowed to modify the data if they are explicitly allowed. Okay, well, thank you everyone. Take care of yourself, study hard, stay safe.